Hello, my name is Janne, and this is an overview of my project, Skin Cancer Classification Using Small Data Sets. So the impetus for this project was the idea that skin cancer is very easily treatable in the first few stages of development, but after it metastasizes, the mortality rate gets extremely high, and not everyone is able to detect skin cancer by themselves or with a dermatologist at an early stage for various reasons. So the data set I used was the HAM 10,000 data set compiled by Harvard, and it separates skin lesions into 7 different categories, and 4 of them are questionable or malignant. And to implement this, because there's only 10,000 images, I had to use image augmentation, but I had to use it in such a way where I wouldn't modify the images to the point where a false diagnosis was created, and this was done through the ABCD rules. The network architecture I used was the inception model created by Google. I only trained the last 2 inception blocks because I don't have the computational power to train the rest. But doing so rendered a high level of accuracy with a low training time due to the inception model's framework. Going over to my project, here's what it looks like. As you can see, I first start by importing the data, the diagnosis part, and then I pair that to image data down here. Further along, I create 1 hot encoding vectors and split it up into train and test data. I then do my image augmentation, which, remember, I selected coefficients carefully. Further down the line, this is what an inception cell looks like coded in Keras. However, in my case, I just imported the model through a Keras method. I then trained the data and performed some accuracy tests. In terms of accuracy, I got 69% plus or minus 0.09% for the validation accuracy. And there's a second measurement I used called binary test accuracy, which basically says if the model can predict if the tumor is at least malignant or benign, then that should be worth something. And on that case, I got 87% accuracy, which means that the model almost 9 times out of 10 will tell you if there is a problem or not. Other than that, I generated a confusion matrix, which talks about true positive versus false positive. And as you can see, the matrix heavily favors the cancerous variety, but that's not too bad because at least we're getting false positives rather than false negatives, which means the potential danger of leaving a cancer unturned is not very present. Thank you for looking at my project.